Year 9. I'm just going to talk you through accessing your home learning tasks. And then I'm going to do a little bit of a lesson on the topics that you've had for this week, just to make sure that you're all understanding them. Okay, so when you go to access your home learning, you should see a screen like this on Classroom, where you've got your tasks. Remember to read this bit, okay? It's telling you here that you need to go through the lesson first, then watch the YouTube video, and then have a go at the homework task. So if I was going to go and have a look at the lesson, okay, this side is my lesson, this side is my task that I need to do last. So click on my lesson, and a My Maths lesson will come up. Now I know you've done the My Maths quite a few times before, so you know what you're doing with it, but just a reminder, before this screen it will ask you to sign in your school login and password, which is Bright and Decagon is the password. Okay, just a few pointers on this. If you're going through the lesson, don't forget that you've got a little button in the right bottom corner that's saying next. Okay, you need to go through all of those to get through that section of the lesson, and when it isn't there anymore, then go on to number 2. Okay, once you've completed all of that lesson on there, you should hopefully have a good understanding of the topic, but just in case, you've got another lesson here on YouTube, okay, where it'll talk you through the same topic. Okay, so after you've done that, you can then click on the My Maths task, which is the actual task that you need to hand in. Now, on the My Maths task now, you're asked for a different login and password. That is your personal login and password. And if you haven't got that, you need to email your teacher and they'll give it to you. It should be a 4-number username and a 3-letter password. Okay, so let's just have a look when you get onto the task. Okay, so you've got here some questions which are asking you to convert some scales and simplify them, and then another question where you're asked to use those scales to find a distance. Once you've done that, press the mark it and then press checkout, and then you need to go back to your classroom and click the box that says that you've completed your homework, so that the teacher knows that you've done it all and it needs marking. Okay, right then. Okay, so if you're still struggling with the topic, if you take a screenshot of the part of the question that you're struggling with and send it to your teacher, they'll be able to give you some feedback on that. Or if you wanted to go on to MathsWatch, you can type in the MathsWatch VLE and go and have a look for a video on the topic on MathsWatch instead. So we're going to have a look at the topic of ratio, because both the higher and intermediate have been set ratio homeworks. The intermediate is more about scale and maps and then going on to similar shapes, and the higher tier are more about similar shapes and going on to similar area and volumes. So just having a look at the ratio and maps then, I've just highlighted here just a few different uses that we have for scales on maps. Okay, so a map can be in lots of different scales. The first one is just a land plan map, which is a 1 to 10,000 map, and that's just ideal for town developers. And as you need to look at more and more area, you get a bigger scale. So on here, 1 to 25,000 would be zoomed out a little bit more for outdoor activities, and then the Land Ranger one is zoomed out even more so that you can see more of the space, so that you could plan a day out, say, and look at different parts of the country. So we need to be able to work out distances on those types of maps. Let's have a look at a couple of examples then when we're trying to work out a distance on a map and what it's equivalent to. So if we were given a map that was given the ratio 1 centimetre represents 1 kilometre, how would that be written as a scale? And there's 4 options here. So these are in different units, whereas the scale is, it doesn't matter of the units, because it's just telling you for every one of something, it means there's 100 of them in real life. It's 100 times bigger. So when we have a look at this now, we've got centimetres and kilometres. So if we put there 1 centimetre is equivalent to 1 kilometre. Okay, so basically we need them in the same units. So the first thing I'm going to do is start to try and convert kilometres into centimetres. Well, I know that 1 kilometre is equal to 1,000 metres. So on that I can say the ratio would be 1 centimetre to 1,000 metres. And then I also know that 1 metre is equivalent to 100 centimetres. So then I can say, well, in that case, I can times this by 100. Okay, so if I'm timesing by 100, I'm going to add another couple of zeros on that because there are 2 zeros in 100. So I've got 1 centimetre to every 100,000 centimetres. Now that they're in the same units, we can just write that as 1 dot dot 100,000. So for every 1 centimetre on the map, it represents 100,000 centimetres in real life. And if we just find the answer on there, is that one. Okay, what I'd like you to do now is just copy down the worked example with the workings out, and then I want you to have a go at the question on the your turn section, writing all of your working as you go, and we'll have a look at the worked answers on that in a minute. I will just neaten up this so that you know these are just the units, because you will need them for both sections. Okay. Okay, hopefully you would have worked out that if we're using 2 centimetres represents 10 kilometres, then using these units over here, you can say, well, 2 centimetres is the same as 10,000 metres, which is the same as 1 million centimetres. Okay, so we've got 2 centimetres is the equivalent of 1 million centimetres, so I can write that as the ratio 2 dot dot 1 million. And then I can simplify that because I've got a 2 here, and I can divide them both by 2, so I end up with 1 is equivalent to 500,000. So that would be this answer here. Okay, I've just got a task for you to have a go at now, which is to put the following lengths in ascending order. Okay, the key word here is ascending. If you ascend a mountain, you're going from the bottom to the top, and so you're putting them in order from the smallest to the largest. Okay, so if you just pause this video now, and I want you to have a go at putting all of those units in order. I would start, just a little clue, with turning them into the smallest unit. Okay, so find the smallest unit there and convert all of the measures into that unit. Okay, so hopefully you've converted them all into millimetres. So I'm going to look for the smallest amount of millimetres, and I've converted them all here. So my smallest amount of millimetres is going to be my 25 millimetres. So that's going to be my starting one. So I've done that one. Next one, I'm going to look for the next smallest amount of millimetres, and that's going to be my 2,500 millimetres. And there are 2 of them. That's going to be my 2.5 metres and my 250 centimetres. So I'll just cross those out because I've done those. So my next one is going to be my 25,000, which is my 2,500 centimetres and my 25 metres. Okay, then we've got our 250,000 millimetres. So we've got on that one is going to be my 250,000 millimetres and my 250 metres. We'll just add that on. So 250,000 millimetres. Let's start a new line, 250 metres. And then last, there's just the one left, so that is the 2.5 kilometres, which comes in at 2,500,000. Okay, well done. That was a lot trickier than it looked. So now we're going to have a look at more of the using the ratio in order to find similar shapes. When you enlarge a shape, you're making it a certain amount of times bigger, okay? So that could even be a half, and you're making it half the size, but you're changing the size of all of the sides. So as you can see here, we've enlarged this triangle here to make that one. And I can see by looking at the sides that the base is 1 here and 3 there, and so I have made it 3 times bigger. Now you can see that it has stayed in exactly the same shape, and the reason it stayed in exactly the same shape is because it's enlarged every single length of the triangle by the same scale factor. So on here I can see BC is 1 and B-C- is 3, so that's also 3 times longer, and it will be the same with the hypotenuse there. And that is what's called a similar shape. Okay, so we can tell if a shape is similar by looking at whether all of the sides have been enlarged by the same scale factor. Okay, so let's have a look at an example of a question you might have. Are these shapes similar? Well, if I was going to answer that question, the first thing I would do is look at the length of the sides. So this side here is 2 units and this one is 3. And the height here is 3 units and this height here is 4. Now if I wanted to look at the ratio of that, I would point out the fact that we've gone from 2 to 3. Right, so we'll have a look at what they've gone up in. So on here I've got one length that's 2 and one length that's 3 on the first rectangle. And on the second rectangle I need to look at the corresponding length, which means the same length in the different rectangle. So this is 2, this is the corresponding length. It's the same part of the shape. So underneath the 2 there, I'm going to write 3. And then the corresponding height here is 4, so I'm going to write 4 in there. So I need to check to see if those ratios are the same. So I'm trying to work out what have I multiplied 2 by to get 3. And in order to work that out, I will do 3 divided by 2. I'll do it over here. 3 divided by 2. Well, I know that 3 divided by 2 is the same as half of 3, which is 1.5. So I've times one length by 1.5 to get the second length. So I need to work out, have I times 3 by 1.5 to get 4? Well, 3 times 1.5 is the same as saying I've got one lot of 3 and a half of 3. So one lot of 3 is 3 plus half of 3 is 1.5. So the length I should get, if I'd had a scale factor of 1.5, is 4.5. And I haven't got that. I've got 4. And so these shapes are not similar. Okay, so we'll start on having a look at the triangles. So on the triangles, I've got the bases, which are easy enough to measure here. So I've got a base of 2 and a base of 1 there. Okay, and then the other bit, it's harder to measure the slanted length of a triangle, so it's easier to measure the height going from the top to the bottom. And I've got a height of 4 there and a height of 2 there. So when I put my table in, put that in there, Okay, I'll put those corresponding lengths in. I've got 1 and 2 for the bases, and I've got 2 and 4 for the heights. So looking at that, I can see that is going to be similar because I've times 2 by 2 to get 4, and I've times 1 by 2 to get 2. So it's got the same scale factor, and so yes, that is a similar shape. Okay, could you please have a go at the 2 examples in the Your Turn section? So if you pause the video and just copy down the worked examples so that you've got some notes there to refer back to. Okay, so when you've filled in all of your lengths and put them in the tables there, we'll just compare them now. 1 has gone to 2 here, so it's times by 2, and 2 has gone to 4, so it's times by 2 as well. So yep, that is similar. When we look at the trapezium, there's 3 lengths that I'd have to consider. The top, the bottom, and then the height as well, because the height will affect the proportion of the shape. If you add the top and the bottom the same, in the same scale factor, but the height in a different one, you might have a really high one or a really flat one. Okay, so looking at that then, from 2 to 4 I've times by 2. Well, in that case, this should be 8, but it's not. And therefore, no, it's not similar. I'm just going to put an activity for you to have a go now at working out whether the shapes that come up on the board now are similar or not. Okay, if you could have a go at those ones then and see if you can work out whether they're similar or not, and then I'll share the worked examples in a minute. Okay, so they're the worked examples, so if you want to pause the video and just have a quick look at those ones. Okay, the last thing that I'm going to have a look at then is just looking at finding missing lengths in similar shapes. So this is when they tell you that a shape is similar and then ask you to find a missing length. So you can see on here, we're trying to find out the missing length, which is represented by a letter. If I write all of my values in my table, I've got on the first rectangle 2 and 8. And the corresponding length, so the length that corresponds with 2 is going to be this length here, which is P. I don't know what that is, so I'll just put P. And then the one corresponding with the 8 is 24. So all I need to do is say, what do I need to times 8 by to get to 24? And that will tell me how many times bigger that rectangle is. So I've times by 3. And in that case, I also need to times the 2 by 3, which gives me P is equal to 6 centimetres. Okay, so that's simple enough. So if you could just copy that example and then have a go at the Your Turn. So I'll just give you a second to pause the video. Hopefully then you will have put your values in the table and worked out that Q would have to be 9 centimetres because the scale factor is 3. It's 3 times bigger. I'm just going to give you some questions now. So if you make sure you've got all of your worked example down for your notes, and then I'll project up some questions. Okay, there are some questions there. So if you pause the slide and then just have a look at those ones, and I'll put the work solutions up afterwards. Okay, spoiler alert, I'm going to put the work solutions up any second. Okay, that's the end of my lesson today then. I'm just going to put on just a little bit of an extension one if you wanted to do them at home. So this video will be shared with you on your classroom so that you can have a go in your own time if you haven't had time to do it all today. So I'll just put a couple of extension bits on, and if you wanted to, you can have a look at those at home. Okay, so this is just when you've got a triangle within a triangle. And just to explain, all I've done is separated the 2 triangles, so that's the top one, and the bottom one is the overall bigger triangle, and then we're doing exactly the same thing where we're writing the lengths in each and working out the scale factor. I'll just project some questions on that there. And that will be everything for today. Okay, so the next thing that's going to come up is some practice for you to do with those if you want to at home, and then I'll put the work solutions on afterwards. I hope you enjoy the rest of your day. See you soon, Year 9. Okay, spoiler alert, I'm going to put the work solutions on.